Hello, it's me, Kostya from Marijuana Garden.
Graphene, the so-called the miracle material discovered as stronger than steel, thinner than paper, better than copper at conducting electricity, and possessing unique optical properties. Graphene is a revolutionary carbon-based material. Graphene's unique combination of superior properties can lead to futuristic products like electronic paper, bendable personal communication devices, and lighter and more energy-efficient airplanes. In the longer term, graphene is even expected to lead to such revolutionary medical applications as artificial retinas. Graphene is discovered in 2002 by European scientists and professors Geim and Kostya Novoselov with their students, when they pulled tiny shavings of graphite, pencil lead, off some discarded Scotch tape and look at it under a microscope. They discovered the possibilities for graphene's practical applications in 2004 and demonstrated that the material can be used in place of silicon or copper to conduct electricity. Their groundbreaking research, conducted at the University of Manchester in England, was recognized by the 2010 Nobel Prize in Physics. In 2014, The New Yorker says graphene may be the most remarkable substance ever recorded, but called much of its celebration hype, saying the product is still too expensive and untamed to be useful. In 2015, graphene is in tests for night vision, artificial muscles, search and rescue robots, bulletproof gear, super-efficient electric cars, cancer treatments, biosensors to look for toxins in food and medicine, and countless other applications. At Mobile World Congress in February 2016, Professor Novoselov explains all the carbon atoms are arranged in a 2D frame, one atom-thick fabric. Despite being so simple, it attracts many superlatives. It's the strongest possible material, the most stretchable, the most permeable, the most conductive. There are other materials that have one of those properties, but here it's combined in one very simple crystal. Novoselov informs graphene has applications in high-frequency electronics, touch panels, optoelectronics, photonics, light, and thermomanagement, batteries, to name a few. It's able to make the internet run 100 times faster and produce flexible, super thin, almost invisible wearables. It's certainly different from the boring old silicon we're used to. After all, 1 million sheets of graphene are just a single millimeter thick. Many think we could be on the brink of a new industrial revolution. The first truly two-dimensional crystal, graphene is the thinnest, strongest, lightest, stiffest material ever made. It's transparent, it's flexible, and it conducts both electricity and heat very well. So, as you can see, if it lives up to its potential, it could change pretty. Graphene's good for all that too. It can even be used to create motion-sensing windows that read gestures, nanosensors that detect breast cancer, and smartphone batteries that recharge in just a few minutes. Sticky tape and pencils, carbon-based materials are already changing the face of electronics, but would likely be immediately replaced by graphene if it is ever fully workable. Graphene can deliver what we all want: bendy phones and ubiquitous embedded electronics and wearables that communicate with each other instantly. We have been talking about flexible, transparent, wearable electronics for years, but so far this field hasn't really delivered, largely became the materials aren't good enough, says Stijan Gusens, postdoctoral research engineer, Nano-Optoelectronics, Institute of Photonic Sciences, ICFO, in Barcelona. Things are not really flexible or transparent, there's always a technological trade-off, but with graphene we can build this whole ecosystem of flexible and transparent, functional devices that can do the same as your phone, but integrate it into your clothes, he adds. There are already graphene-coated ski jackets, mattresses and performance underwear, Snigger, but the next level of integration using graphene-based inks is all about wearable electronics, aka smart clothing. A shirt with graphene ink in, say, a logo or a pattern could unlock a security door for an employee, while a paper wristband with graphene inks upon it could become an electronic ticket. In the world of optoelectronics, graphene sensitivity is helping create spectral sensors for wearables that use light to reveal. The findings could revolutionize the production of the heavy water composed of a rare form of hydrogen called deuterium, which is expensive to manufacture and purify with existing technology. Others have found uses for graphene essentially to create superfine sieves for desalination, catching the salt from seawater, so creating an inexhaustible supply of drinking water, cleaning up oil spills by removing all impurities in water, extracting radioactive materials from water, separating hydrogen ions, and even for mining and fracking. And then a light appeared. Graphene could also be used to clean up nuclear waste contaminated with radioactive tritium, another hydrogen isotope that can be separated by the graphene filter, scientists said. Essentially, graphene is the finest known sieve. It can sieve particles smaller than an atom, said Marcelo Lozada Hidalgo of Manchester University, the first author of the study published in the journal Science. Graphene has already astonished the world of materials science with its range of unusual characteristics, such as its atomic scale thinness, extreme strength and high electrical conductivity. The latest study, by a research team led by Professor Geim, discovered another novel property of graphene, its ability to filter the different atomic isotopes of hydrogen, namely tritium and deuterium, from ordinary hydrogen. The rare form of hydrogen, deuterium, is only present in graphene could be used to detoxify nuclear waste. The findings could revolutionize the production of the heavy water composed of a rare form of hydrogen called deuterium, which is expensive to manufacture and purify with existing technology.